Okay, now I'll give you the name of molecular orbitals. When 1s combine with 1s, what will be the name of the molecular orbital? What is the name of the bonding molecular orbital? What will be the name of the anti-bonding molecular orbital? See, when 1s combine with another 1s, two types of combination takes place, maybe due to addition, maybe due to subtraction. These are the name of molecular orbital. As you know, S and S is spherical in shape. When 1s overlap with another 1s, then what type of bond will form? The bond is called sigma, because head-on overlapping takes place. And this is suppose 2px and this is another 2px. This type of overlap is called head-on overlap, and head-on overlap produce pi bond, you know. So based on this, whether after combination they will form sigma or pi, based on that you will get the name of molecular orbital. Since S combined with S, they produce sigma bond, that is why the name of the molecular orbital is called sigma 1s. You combine 1s and 1s, that's why 1s is given, and since they form sigma bond, that is why the name of molecular orbital is sigma 1s. And this is combination, that's why due to combination, due to addition, they always produce bonding. So molecular orbital is represented by sigma 1s b, b for bonding. And when the subtraction takes place, 1s minus 1s, then they will form the anti-bonding molecular orbital, and this anti-bonding molecular orbital is represented by sigma 1s star. So when two atomic orbitals combine, they form two molecular orbital. One is called bonding, one is called anti-bonding. Bondings are formed due to addition and anti-bondings are formed due to subtraction. Similarly, when 2s combine with another 2s, they form the bonding molecular orbital, which is represented as sigma 2s bonding, and when subtraction takes place, you will get the corresponding anti-bonding, and it is represented by sigma 2s star. In the main points I have given, bonding molecular orbital are represented by sigma, pi, delta, like that, and anti-bonding molecular orbitals are represented by the star symbol. That's why in anti always you have to use star. So this is for 1s and 2s. Similarly, in case of 2p, as you know, one is called 2px, one is called 2py, one is called 2pz. 2p subshell contain 3 orbitals. So in molecular orbital theory, one thing you should know, because p orbital can form sigma also, pi also, this internuclear axis is considered as the z axis always in molecular orbital theory. This is considered as x and this is considered as y. So this p orbital is called pz orbital, this is said to be the px orbital, and this is said to be the py orbital. So when this z orbital overlap with another z orbital, they will form sigma or pi. They will form sigma because head-on overlap takes place. But px and px, when they overlap, they will form pi. Similarly, py and py, when they combine, they produce pi. So that is why for 2pz, you will get the sigma molecular orbital, and for x and y, 2px and 2py, you will get pi molecular orbital. Always you remember, in case of molecular orbital theory, this internuclear axis is considered as z axis, and that is why z produce sigma. So now I will give you for 2pz orbital, when combined with 2pz, another 2pz, then they produce sigma 2pz bonding molecular orbital, and 2pz, when subtraction takes place with another 2pz, then they produce sigma 2pz anti-bonding star. So every atomic orbital produce two molecular orbital, one is bonding, one is anti-bonding. Similarly, 2px, when combined with another 2px, the molecular orbital is now not called sigma, it is called pi, because 2px overlap with another 2px, they undergo lateral overlap, and due to this lateral overlap, they produce pi bond, and that is why the molecular orbital is named as pi molecular orbital. So 2px plus 2px, you will get pi 2px bonding, and when subtraction takes place, it produces the corresponding anti-pi 2py star. Similarly, 2py, when combines with another 2py, they produce pi 2py bonding, and 2py, when subtraction takes place, then it produce pi 2py star, I mean the anti-bonding molecular orbital. So these are the name of molecular orbitals. As I have told you, these are the atomic orbitals. When atomic orbitals combine, they form the molecular orbitals. So what are the names of molecular orbitals, that you have to know, and when you know the molecular orbitals name, then you can write the electronic configuration of the molecule also. Already you have written the electronic configuration for your different atoms. For example, hydrogen you have written like this, 1s1. Now if the question asks write the electronic configuration of hydrogen molecule, so how to write the electronic configuration? For atom, you know the atomic orbital. Similarly, molecule also contain the molecular orbital. So when you write the electronic configuration of molecule, then you have to use this molecular orbitals. In case of hydrogen molecule, if you want to write hydrogen molecule, means hydrogen contain 1 electron, hydrogen molecule means 2 electron. So its configuration will be like this: sigma 1s bonding to sigma 1s star 0. I will give you how the electronic configuration come. So this is the electronic configuration for hydrogen molecule. So in exam, the electronic configuration asks maybe for atom, maybe for molecule. If atom is given, you use atomic orbital 1s, 2s, 2p, this type of atomic orbital. And if molecule is given, then you have to use molecular orbital. And when you fill up the electrons in molecular orbital, same rule you apply as you have applied in atomic orbitals. I mean Pauli principle, Abgaud principle, Hund's rule, same method you have to apply in molecular orbital also. So we'll write the electronic configuration later. So these are the name of molecular orbitals, and you should know the symbol and name of these molecular orbitals. Now the most important part of this molecular orbital theory, that you have to draw some diagram, and which are called molecular orbital diagram. So I'll show you the molecular orbital energy level diagram. This is very important. For one molecule you have to draw the diagram. In exam, this question you will get, draw the molecular orbital diagram for oxygen molecule, nitrogen molecule, like that. So to draw the diagram, first time I will take the simple example, hydrogen. To draw the diagram, you should know about the format, how to draw. This is your energy level, that's why it is called energy level diagram. So this side energy going on increasing. In this position, atomic orbital of hydrogen atom. In this position, atomic orbital of hydrogen atom. And here you have to write in the middle position, molecular orbital of hydrogen molecule, because you know when atoms combine, they form the molecule. So atomic orbital of hydrogen, as you know, hydrogen contain 1s orbital. So this is your 1s orbital for this hydrogen, and this is your 1s orbital for this hydrogen atom. As you know, hydrogen contain 1 electron, this hydrogen also contain 1 electron. When these two atomic orbital combine, they form two molecular orbital. One is called sigma 1s bonding, and one is called sigma 1s star. Since bonding have lower energy, so bonding you have to draw here. This is the sigma 1s bonding molecular orbital, and anti have higher energy, that's why you have to write here. This is sigma 1s star. So when 1s and 1s combine, they form two molecular orbitals. You have to combine like this. When this 1s combine, they form two molecular orbital. One is sigma 1s bonding and one is sigma 1s anti-bonding. So how many electrons now? This hydrogen atom contain 1 electron, this hydrogen atom contain 1 electron. After combination, 2 electron. So that 2 electron you have to fill up in molecular orbital. Now when you fill up in molecular orbital, first time you have to fill up in lower energy orbital. So since one orbital contain maximum 2 electron, so both the electron will enter in sigma 1s bonding. The anti will be vacant. This diagram is called molecular orbital energy level diagram for hydrogen molecule. So here you have seen the hydrogen atom configuration, you know 1s1 as I have drawn. But if you want to write hydrogen molecule configuration, this is the molecule configuration. Sigma 1s bonding, this orbital contain how many electron? This orbital contain 2 electron. So here you write 2 electron, and sigma 1s third, it is vacant. That's why you can write sigma 1s third 0 electron. And this is the electronic configuration for hydrogen molecule. So from the diagram you can find out the electronic configuration of the molecule, and also you can find out some properties. I will tell you later whether the molecule is diamagnetic or paramagnetic. What will be the bond order for this molecule? Bond order means how many bonds will be present between two atoms. So this type of property you can find out from this molecular orbital energy level diagram. In next class I will tell you about this topic. Thank you.